In section 1.9, we're going to solve real-world problems involving ratios and rates of change. Again, we want to first look at our objectives. We're going to formulate a rate of change. We're going to use a ratio or rate of change to solve a problem. We're going to convert a ratio to a unit rate. We're going to compare a ratio for a real-world situation. And then we need to look at our key words. There's only one in this particular example, a unit rate. It's a rate that shows how many units of one quantity in the numerator correspond to 1 unit of the second quantity in the denominator, such as miles per hour. So if you've ever seen the phrase 55 mph, that means 55 miles per hour. Here's some other examples of where you use ratios: dollars per hour, miles per hour, cups per day, gigabytes per month, principal plus interest plus escrow divided by the month. If you want to talk about your mortgage payment. And so what you need to do on the TEAS test, you encounter a range of real-world problems that involve ratios and rates of change, so you want to understand these concepts and how to put them into practice. In the TEAS book, it shows that a ratio shows how many times one number is contained within another number and is often represented as a fraction. So you can see this example here, 2 to 3 or 2-3 as a fraction, and you usually want to put your fractions in lowest terms. Then we get down to rates, unit rates, and rates of change. Ratios with units are called rates. So an example will be 2 cats to 3 dogs, or 2 cats on the top of a fraction bar, 3 dogs on the bottom, 7 absents to 10 presents, 7 miles to 2 hours. These are all ratios, but since they have units of measure, they are called rates. And a unit rate is a rate that is expressed per 1 unit. For example, 7 miles over 2 hours. Once you do that as a unit rate, you would take the 7 divided by the 2 and get 3.5 miles over 1 hour, or 3.5 miles per hour. So to find a unit rate, simply divide the numerator by the denominator. And this unit rate is also called the rate of change. In your handouts in Canvas, we have the ratios, rates, and unit rates all condensed down to one handout. So you can see a ratio is a quotient of 2 quantities. And this is another way that you can write a ratio. It's 1 to 2, or as a fraction like it's in your TEAS books, or the third example that was in your TEAS books. A rate is a ratio that compares different kinds of quantities, so it has 2 units of measure. And a unit rate is a rate with a denominator of 1. And you can see this is exactly the way it's explained in your TEAS textbook. One of the things that was not really covered in your TEAS textbook, but is really important, is writing a ratio or rate is a fraction. It says the order of the quantity is important when writing ratios. So you got to write the first number of the ratio as a numerator, and the second number is going to be your denominator. And to write ratios and rates in simplest form, you just simplify this as you would a fraction, except ratios cannot be written as a mixed number fraction. So if I had 7 over 2 as a fraction, I could change that to 3.5. Well, that's a fraction. It's okay to write it. 8 over 6, 1 2/6, which is 1 1/3 is a fraction, is fine. But as a ratio, you cannot do that. The 7 over 2 must still stay 7 over 2. The 8 over 6 can be reduced to 4 over 3 as a ratio, reduced in simplest form, but it still cannot be written as a mixed fractions. I do not remember seeing this in anything in your TEAS textbook, but just be aware of this. In your TEAS textbook on the next page, it talks about using ratio and rates of change to solve problems. I'll let you read this example here. And then the next 2 examples, what I want to do is get down to this graph here. This is another way that you can show rate of change. If you've ever had to do some graphing on a Cartesian coordinate system, you've seen examples like this. And so to find the rate of change, what you do is you take the difference in the y values and subtract them and put them on top of a fraction bar. This is y2 minus y1 divided by the change in the x coordinates, which is x2 minus x1. So in this particular case, I was using the 3 weeks and $75 and 8 weeks and $200. I'm going to go 200 minus 75 on top, get that to be 125. And then the 8 minus the 3 is going to give me 5 weeks. Then to change that to what we call the rate of change, we want to simplify that to a unit rate. And so we do that by taking 125 divided by 5, we get 25 over 1 week. So our slope formula below which is y2 minus y1, and the difference between x2 minus x1 is the example you would use to find the rate of change. So I'm going to let you look at this example here to understand how to find the rate of change. This example here, you had used 22 cups of flour to make 6 cakes. In this particular example, we only want to make 1 cake. So we would take our ratio, created as 22 cups over 6 cakes. We can either say we're going to divide the top by 6 and the bottom by 6. In other words, convert it to a unit rate, take the numerator, divide it by the denominator. You get 22 over 6, which is 11 over 3, which is 3 2/3 cups over 1 cake. Now, in the previous example, I said we cannot write a ratio as a mixed number. But the numerator can be a mixed number, or the denominator can be a mixed number. Just the whole ratio cannot be a mixed number. So all unit rates must also be labeled in the numerator and the denominator with their units of measure. Once you understand how to do this and how to simplify a ratio, almost exactly like you would a fraction, then you should be ready for your practice problems. Again, I've worked all these out and posted the answers in a key in Canvas. Good luck on this section.